We'll talk more about the shooter bias studies of Carell and colleagues in Chapter 13, but I wanted to mention them here as these studies highlight the potential dangers of an over-reliance on the automatic processing system, particularly when this processing system is biased. You can read about the real-world case that inspired Carell in Chapter 13, and I also posted a video of it on Canvas for you guys to check out. Carell had the research question, are police more likely to shoot Black suspects? Carell and colleagues predicted that the answer to this question would be yes, and further, that racial stereotypes would underlie or drive this bias. So where does automatic processing come into play here? According to Carell and their predictions, they argued that police officers would be relying on this automatic processing system in these types of scenarios. And so they write that police officers face situations in which behaviors and objects are unclear. For example, it may be dark, the object in question may be hidden from plain sight, and they must make sense of that ambiguity quickly in order to protect themselves and those around them. Because of this lack of clarity and time pressure, they may rely on salient secondary cues. So things other than the crucial, central, relevant aspects of the scene at hand. Instead, these peripheral, irrelevant cues, such as the suspect's race or gender, to interpret the situation. So Carell and colleagues are arguing that racial stereotypes are a determining factor in these tragic real-world events. And to support this claim, they cite data from the Department of Justice, the DOJ 2001, that indicates that per capita, police are roughly 5 times more likely to shoot a Black person than a white person. But when we look at these real-world statistics and these real-world events, it can be very difficult to tease apart the various causal influences, that we look at these real-world events as complex and multifaceted. And in research, we have this vital need when we make causal statements. As we mentioned in the last chapter, we need to isolate a potential causal influence. And so Carell and colleagues brought this particular phenomenon into the laboratory. And obviously we can't exactly replicate these scenarios, as we can't give our participants guns and have situations in which individuals may shoot each other. And so instead we have a computer simulation of this task. Participants are seated in front of a computer screen, and they are asked to make very rapid decisions within milliseconds. And the decision is to shoot or don't shoot, depending upon the object that the target individual on the screen has in their hand. And so with each trial, we have a variety of backgrounds, and we have individuals who are superimposed onto those backgrounds holding a variety of objects. And so the target individual in the screen may be holding a weapon, a gun, or a non-weapon, a wallet, a Coke can, or a cell phone. And it is the task of the participant to, as quickly and accurately as possible, determine whether the object in the person's hand is a weapon or a non-weapon, and to indicate that choice by clicking shoot or don't shoot. And so given this type of task, there are 2 types of mistakes that our participants could make. So the first type of mistake is a miss. So in this case, our target individual on the screen is holding a weapon, but the participant clicks don't shoot, indicating that they perceive that object to be a non-weapon. And so they have missed the weapon or misidentified this object. Or we could have the false alarm error. So in this case, the target individual on the screen is holding a non-weapon, the wallet, the Coke can, or the cell phone, but our participant has selected the button to shoot. So misidentifying this non-weapon as a weapon and indicating to shoot. And it is this false alarm error that Carell and colleagues are particularly interested in because it is that type of error that mirrors the error in the real life scenarios that inspired this research. And so, given what we know about the automatic processing system, individuals are making very rapid, almost reflex decisions. We should expect error in this process. But Carell and colleagues are arguing that this error will not be random error, but instead we'll see that there are very predictable patterns in the types of errors that people will make, and the error will be influenced, according to them, by racial stereotypes. And so if you see in this depiction of their results, we have number of errors per 20 trials on our y-axis, and we have here condition as determined by the race of the target individual in that particular trial on the screen. That is our x-axis. And as you can see, our false alarm error, so misidentifying a non-weapon as a weapon and clicking to shoot, is the most common type of error, but only when the target individual on the screen is Black or Hispanic.